Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zahira binti Mazlan. I'm from BA 2733B. Today we explore a growing crisis that could shape the future of one of the Malaysia's most important growth industry. Under the title, The Talent Drought Malaysia Semiconductor Face a Skill Shortage Crisis, we dive into how a skill shortage can impact semiconductor sector ambitions in Malaysia. With the global demand of semiconductor surging, Malaysia aims to double its output and climb up its value chain. Yet the country reportedly needed an additional 60,000 engineers to reach their goals. In this video, we examine three major causes of skill shortage, the three impacts of skill shortage, and we propose three solutions for these issues. Let's go to the first part of this video, which is the three major causes of skill shortage. In this part, I will explain about the three major causes of skill shortage. The first one is mismatch between education output and industry needs. Many graduates lack the practical industry-ready skill needed for semiconductor design, fabrications, and advanced packaging. University and technical programs have not kept pace with the rapidly evolving demands of semiconductor technology. Number 2. Brain drain and talent migration abroad. A significant number of qualified engineers choose to work overseas, for example, Singapore, where compensation and opportunities are more attractive. This annual loss of skilled workers weakens Malaysia's ability to build and sustain a deep talent pool. Number 3. Underinvestment in R&D and limited semiconductor infrastructure. According to the Central Bank, low spending on research and development and limited local infrastructure constrain the growth of high-value semiconductor work. Without sufficient facility, labs, and advanced design capabilities, local engineers have fewer opportunities to grow specialized skills. The next part of this video, which is the three impacts of skill shortage. The first impact is staggering Malaysia's ambitions to climb up the global semiconductor value chain. The lack of skilled talents limit the country's ability to move beyond basic assembly or testing, restricting progress toward integrated circuit design, wafer fabrications, and advanced packaging. Without the right human capital, Malaysia risks being locked into lower value segment of global supply chain. Number 2. Loss of potential foreign and domestic investment. Talent scarcity may deter new investors and companies from setting up operations locally or delay scaling up of existing operations. The country might miss out on high-value, high-tech projects that require specialized skills. Number 3. Waste, resource, and risk of white elephant facility. Building advanced semiconductor facility without sufficient talent risk underutilizations, labs, and infrastructure may remain idle or operate at suboptimal capacity. This undermines the long-term sustainability and competitiveness of industry, jeopardizing jobs and national returns on investment. Last part of this video, I will propose three solutions for these issues. The first one is boost education and training, align curriculum with industry needs, prevent university and technical vocational programs to include hands-on training in IC design, wafer fabrications, packaging, and other semiconductor-specific skills. Strengthen partnership between academia, technical institutes, and industry to ensure graduates are industry-ready. Number 2. Improve talent retention and attract diaspora or foreign talent. Offer competitive salary and benefit to prevent brain drain to neighbor countries. This includes matching industry pay to global or regional standards. Incentives measure engineers to abroad to return and considers allowing fresh graduates or specialists into key roles to fill urgent gaps. Number 3 is increase R&D investment and build advanced local infrastructure. China sustains funding into research and development to build a local capabilities in cutting-edge semiconductor technology, develop labs, semiconductor design parts and advanced manufacturing facility so that engineers have opportunities to practice, innovate and grow. In conclusions, the talent drought in Malaysia semiconductor industry isn't a merely human resource problem. It's a structural challenge that threatens to stall national ambition in fast-moving global sector. To become a major global player rather than remain a back and assembly hub, Malaysia must act decisively across education, compensation, infrastructure and policy. By aligning its education system with industry needs, improving retention and investing in R&D and infrastructure, Malaysia still has a realistic shot at turning the looming talent drought into foundation for long-term semiconductor strength. That's all for me. Thank you for watching.
As countries pour money to beef up their chip prowess, Malaysia's semiconductor industry is facing an intensifying battle for talent. Industry players are working closely with the government and universities to plug the gap in a bid to address the acute shortage of skilled workforce. Melissa Go with the story.
Azwani Abdul Aziz has been working in the semiconductor industry for about a decade. A trained process engineer, she's now involved in front-end high-tech manufacturing, where 1 in 4 employees is female.
I like it. Right now, a part of the IC substrate that we make is for the AI. So I'm very excited actually to be a part of a high-end substrate industry.
Azwani joined Austrian-based AT&S, a leading supplier of high-end printed circuit board and IC substrates 2 years ago. Standing long hours in a clean room with a jumpsuit coverall was no issue for her. She was sent to the AT&S Chongqing plant in China for training. Azwani had already received several job offers after she started working at the Kulim plant.
Actually got lah, because right now it's also have a few company want to open same industry like AT&S. So the one is depend on you lah, whether you want to accept. The most important other than salary lah is a knowledge that I gain lah.
Her employer, AT&S, said there's an acute shortage of skilled engineers in the country. Its newest plant in Kulim, costing over $1.8 billion, will create some 6,000 jobs when operational by year-end.
I've never seen the talent shortage as serious as these few years, especially in the semiconductor, in the high-tech manufacturing. There are many investments, not only Malaysia, but also all over the world, as we can see. So there is obviously a talent war out there.
Since you mentioned about the talent war that's ongoing in the industry, how do you address the issue of brain drain?
Generally, there are a few things that people always looking forward to is the development opportunities. And also, they look at the culture of the company, leadership, the management, and some of them, they love making new technology and products. Of course, we need to offer competitive packages and train the younger generations to master the processes.
The government said that the semiconductor industry is in need of 50,000 skilled engineers, and Malaysian universities are currently producing about 5,000 engineers a year.
Now, meanwhile, US tech giant Intel, that's been in Malaysia for some 5 decades, is investing another $7 billion to expand its operation here in Penang. Now, this new advanced packaging facility, scheduled to be completed by the end of this year,
and it will create some 4,000 high-paying jobs. To meet the growing demand, the National Semiconductor Strategic Task Force is looking at allowing foreign graduates to work in the industry. Also, MNCs are encouraged to train young engineers.
So there is a program that we look at for technicians. There's now another program we look at the engineers. So we can try to solve internally the war on talent. I call it the war on talent because everybody is short of talent and they are here looking for a talent. They are everywhere over the world.
Meanwhile, more tech giants are linking up with universities to tailor-make courses to plug the talent gap. With the global semiconductor industry projected to become a $1 trillion industry by 2030, Malaysia is racing against time to create the right semiconductor ecosystem to bolster exports and future economic growth. Melissa Goh, CNA, Kulim, Kedah.